Welcome back, students, to another lesson. In today's class, we will be looking at question number 4, which is alternating current. So we're at question number 4, which is AC circuits, right? Going to be looking at AC circuits in today's lesson. AC circuits. So for this question, they give us the frequency, which is equals to 50 hertz, and the root means square value, so I root means square value is equal to 40 amps. So for the question 1, what they want us to find is the time sorry isn't it they want us to find the current at t is equal to 0,0025 seconds. Pause. Maximum position, right? So to do that, we got all our values. So to do that now, you need to know that the period is equal to 1 over the frequency. So we have 1 over 50 hertz, which gives us a value of 0,02 seconds, right? So when we draw our graph, which is normally sine wave, we have t is equal to 0,02, and if we halve that, we have 0,01, and our maximum is at 0,005, and our minimum is at 0,0075. Now we have to find our maximum current, so our I maximum is equal to the root means square value multiplied by the square root, right? To get our maximum. So our maximum will be 40 multiplied by root 2, which gives us an answer of 56,56 amps, right? So that is the maximum at this point. So this will be positive. Let's just get the red pen. This will be positive 56, and this will be negative 56. Okay, so now that we have found our answer over there, what we're going to do is we are going to find the angular, right? So we know that AC current is from an electric motor, right? So we have an electric motor, right? So that's why we have to calculate the angular, and the angular is equal to 2 pi frequency, right? So we're going to have 2 pi multiplied by the frequency of 50 hertz, right? And we have an answer of 314,159, right? Rads per second. So over here we have radians, right? And we need to get this equation before we can substitute the time in, right? So our equation is going to be I is equal to 56,56. Sorry about that. So to get the formula, the formula is equal to the maximum multiplied by sine wt plus minus the phase shift. Okay, so then once we substitute that, we have 56,56 multiplied by sine, and then our angular, which is 314. So our angular here is 314,159, and our maximum here is 56,56 3,4 comma 159, and that will be t, and then plus minus phase shift 0. So that's not given to us. Okay, so now you want to make sure that your calculator is in radians mode. Okay, so what we will do is, let me just get out my calculator. So I'll put my calculator over here. So now what you'll do is you'll press shift, okay, shift plus mode plus radians. Okay, so let's do that. Shift, mode, and over here let me just make my cursor a bit bigger. Okay, over here you can see degrees, and we're gonna shift to radians. Okay, we're gonna go back, go clear this AC. Okay, now we're going to substitute this into to get an answer for us. So we're going to do, so t, what is t? So if you look here, sorry, let me scroll up. If you look over here, we can see that t at 0,025 seconds, right? Pause maximum position. So what we're going to do is, from this position, we are going to pause maximum is going to add 0,025. So what we will end up with is, we're going to have, so t is equal to 0,0075, right? And we're going to substitute that into the equation. So we have 56,56 multiplied by sine, open brackets, angular, which is 314,159, and multiplied by time, which is 0,0075, and then close the brackets, and then we're going to get an answer. So let's put that 56.56 multiplied by sine, ignore that, sine open brackets, 314.159 multiplied by 0.0075, close the brackets. So as we put all those values in, it's 56.56 multiplied by sine 1314157. So we see we get an answer of 40 amps, or 39,995 amps. And we can confirm with that, we can confirm with the graph. Let me just close. Okay, so you see this, right? So if we click on more, if we click degrees, close the thing, equals to, you see it giving us 2,325, right? So when we come on our graph, we can see that 0,025 seconds or 0,075 seconds, it is at this position over here, estimation, right? It's at the position here, whereas 2,23 is very close to the x-axis, and you can see that's not the correct answer. So our correct answer should be in degrees, and that is our correct answer of 40 or 3,99 amps. So that is our equation, and those are our answers. So now I'll close the calculator and do the second part of the equation. So now number 2, it says calculate the time. Calculate the time. So they want us to calculate the time when I is equal to 14,14 amps, right? From maximum, right? From maximum. So what we'll do is I'll just copy this one over here because this one is very important. Copy this, copy, paste it over here, paste it, and then I'll copy this formula here. So let's copy this formula, copy, paste it over here. Okay, so now they want us to calculate the time when I is equal to 0,14,1 14,14 amps, right, for maximum. So they want us to get the position. I would say that our answer should be around somewhere over here, right? But we need to find the time. So our time has to be greater than 0,05 and then less than 0,01. You could get this time, but they want this time over here. So this time is correct, but they say in the question it says the time measured from maximum. So this time is from 0, right? Let me just zoom in. So we have 0 over here. So this one is from 0, but they do not want from 0, they want from maximum. So this is our maximum, right? And they want us to get 14,14, right? They want to know what is the time at this position. Okay, so what we're going to do is very simple, guys. All you have to do is plug and play. So now we have 14,14 equals to 56,56 multiplied by sine, open brackets 314,159 open brackets, and we're going to have our time there, right? So now what we're going to do is manipulate it, right? So let's manipulate it. So we want to find the time. So time is equal to sine to the minus 1, open brackets, 14,14 over 56,56, right, all over 314,159, right? And that gives us an answer. So time here is equal to I already did this, so okay, let's open the calculator just in case. Calculator, let's open the calculator in case. More, make sure your calculator is in radians. Now we're going to clear all of those, double check. Okay, calculator is in radians. We have your radians, degrees. Okay, let's plug this in. We have, sorry guys, open bracket. So on top we have sine, and then we have 14.14 divided by, sorry, let's erase this. We have to 14 point divided by 56.56. Then we're going to close this one, and then at the bottom we have 314.15, 31.159, and that gives us an answer of Okay, so our answer is 0,0007887, right? So let's write that over here. Let's round it off to 0, 0, 0, 0,008, right, seconds. That is from 0, right? So if we go to our graph, let's just enlarge this graph of ours. Wait a minute. Let's first shrink this down, move it up here. Okay, those points are not really important at the moment, so what I'll do is I'll zoom it in again. Okay, so now when we look at it, we have a time here of 0,0007008, right? And you can see that our answer makes sense. Whereas if we had it in degrees, let's go back here. If I had it in degrees, we have 0,0000013, which does not make sense, right? So you have to keep your calculator in radians. Okay, so let's go back, keep it in radians, guys. And now what we're going to do is the period, right, is equal to 0,02, right? So they want from maximum, they want this coordinates, right? So we have 0,01, right? We're just going to subtract that. So our t is equal to 0,0. So we have 0,0.01, right? 0.01 minus 0.0008, right? And that will give us an answer of, so let's do that, 0.01 minus answer. So we have time, which is 0,009. This answer is from maximum. Thank you for watching today's lesson, and I'll see you in the next recording. Bye.